Good morning once again. And my name is Cosmos Senor Omega, and as already introduced, so I'm a research fellow with URIC, which is a research center with the University of Energy and Natural Resources in Sunyani. So today I'm going to discuss with you assessment that we did in terms of urban heat island warming in Greater Accra, or over Greater Accra. And I'll walk you through some aspect of a little bit of an overview on what urban heat island itself is, and then some materials that were used, and then the method, the results, and then some discussions, and then through to the conclusion aspect. Okay, so in terms of urbanization, the population of Ghana since the 1960s has been increasing. And at this rate, we are currently having about 30 million and over people living in Ghana. Out of this, about 58.62% live in urban areas. And if you look at what we see in Accra, the percentage of the number of people who live in Accra is over 5 million. And even though Accra is one of the smallest, or it is the smallest in terms of size in Ghana, that's the regions, it is the one that is having the most people, or is hosting a lot of people. So out of this, the population density is about 1,680 persons per kilometer square. So this is a very dense area in terms of population. And once the population is also dense there, it means that you have a lot of activities going on, and this can influence the natural environment that we have in terms of cutting down of trees for making way for housing, in terms of construction of roads, burning of fossil fuel, and all that. So urbanization, it's the percentage is very high, especially in Accra. Now, taking you back to some images, we'd see that those of us who know Accra very well, especially around the airport, you'd see that there had been a lot of changes. This is Accra, just close to the airport area, where if you compare the images, you see that there had been a tremendous improvement in terms of infrastructure over there. And then even if you look at the airport itself, how it used to be some time back and what we see now. So there had been a lot of changes, and it keeps on going and going, since human beings would always want to develop and then make life comfortable for themselves. So this actually influences how we use our land. Now, urban heat island itself is an area where the heat is, or temperatures are very high than its surrounding rural areas. And this is a heat dome that covers an area as a result of its makeup. So one of the things is the land surface cover. And most of the time within the cities, we see a lot of pavements, a lot of asphalt, and all that. And these things are greater absorbance, or they absorb heat a lot and retain them, and then release them gradually, especially at night. And then there are less tree cover within those areas as well, which means there's less land transpiration, and then water evaporation, and then also evaporation from the soil as well. But when you go to the rural areas, you could see that most of those areas do have all these features which help in cooling their surroundings. So this is what creates the urban heat island. Now, if you look at this image as well, you would see that as time passes, so through to the night, once there is daytime, the sun rises, it hits the ground, temperatures increase because of the makeup. Now at night, we lose the temperatures, the heat into the atmosphere. Now when it is being released, especially at night, within the cities, you see that because these surfaces absorb a lot of heat and retain them, they release them gradually at night. And therefore, during the night time, that's when this heat still exists in the atmosphere. So the heat stress penalty is high, especially at night within the cities. And this is what causes the urban heat island. So this is just a view of how the whole process looks like and how it affects our health, especially in human beings, in terms of the cardiovascular diseases, in terms of heat strokes that it gives us. It also gives us gastrointestinal hemorrhage, which is mostly related to bleeding within your intestines and all that. And also it increases the temperature over the city, where temperatures become very high, and then the heat stress becomes very high for people to endure. So all these effects are there, and they exist also in our country, but most of the time we attribute them to other things rather than even urban heat island itself. There have been some studies over the years, especially around the world, trying to assess this heat island. In Ghana here, the study, as at the time we did this study, it was very limited. In 2006, Menu et al., they used the long-term temperature and the population data to assess the difference in temperatures over Accra and in Kumasi. And they realized that temperatures were high in the urban areas as a result of urbanization. Now, in 2012, Dua et al. Also used similar principle and also a remote sensing technique to assess the urban heat island in Takwa. And then in 2015, Kumi Boate et al. Also used remote sensing to assess this in Secondary Takrade. However, within those periods, none of them had really used remote sensing approach in assessing the urban heat island in Accra, which is the capital city of the country, where a lot of activities go on. Again, they had also not looked at the temperatures in terms of extreme temperatures and the influence of urbanization on them. So this study was conducted, and then a comprehensive assessment of this UHI warming, that's the urban heat island in Greater Accra, was carried out. What we did was that we classified the land cover to determine the urban growth, and also we mapped out the UHI, that's the urban heat island, to determine its intensity and then the spatial extent. And also we used what we call the urban thermal field variance index. I will explain later. And also the study also assessed how temperature extremes and urbanization influence the UHI warming in the region. So with all these things, it means we're going to need some data for our analysis and all. So the first thing that we did was there was a preliminary assessment where we checked for some temperature, especially along the coast. I realized that especially at night, Tema and Accra were warmer than the other towns. And Tema and Accra, as compared to Akachi and Saltpond, is much more urbanized than these areas. So there was an evidence that there could be urban heat island existing within those steady areas. So we decided to narrow down to these areas to assess them further. So our study area now was narrowed down to the Greater Accra, where we assess the urban heat island. Now, with the workflow, we took data from Landsat images, which was from 1991, 2002, and then 2017. To assess, this was going to help us to do the land cover classification and then help us to detect changes in land cover and then use it for the urban growth. Then also out of the same satellite data, we're going to retrieve the land surface temperature, which was going to help us in mapping out the urban heat island and then the field thermal variance, urban thermal variance field index. Also, we obtained data which span from 1980 to 2017. That's minimum and maximum temperatures from Ghana Meteorological Agency. And this data was quality controlled and processed with ClimaPACT2 and then RH test version 4. And also this was used in calculating the trends for the extreme temperature analysis that we were going to do. And out of these, we did the detection of the urbanization effect and also the level of contribution, which I will explain later. All these were supposed to help us to understand the effect of urbanization on temperature and the ecosystem, and then the driving factors of the extreme changes, extreme temperature changes that we would see. So this is a description of the extreme temperature indices that we use for the study. If you look at the indices, we have the TXM, which is the average daily maximum temperature. So the daily maximum temperature, we are looking at the average that exists within the period. And then the second one is also an average daily minimum. So out of all the minimum temperatures, we are looking at the average temperature that exists within it. And then the mean temperature, we are also looking at the average of the mean temperature. All these are going to help us in understanding the extremes in terms of the intensities. Then we have the diurnal temperature range, or the daily temperature range, which is an average range of maximum and minimum temperature. So this is a subtraction of the minimum temperature from the maximum temperature. And then we have the coldest day, which is the minimum of the maximum temperature. So maximum temperatures are mostly noted as the daytime temperatures, and then minimum temperatures are noted as the nighttime temperatures. So the minimum minimum temperature gives us the coldest night, and then the warmest day, which is the maximum of the maximum. So out of the maximum data, the day that we had the maximum temperature, that's what gives us the warmest night, the warmest day, and then the same thing for the rest. The fraction of days, these ones are based on percentile. So we use the 10th percentile and then the 90th percentile to denote the cold nights for the 10th percentile, and then the 90th percentile for the warm periods. And then the maximum going for the daytimes, and then the minimum going for the warm nights, the night times. And this one was actually to get the frequency. So this determines the frequency of the warm extremes. And this is similar to the indices that was looked at by Jacob Ejekum, doctor, recently when he presented, I think during the 19th seminar. These are some equations that was used in mapping out the UHI, and I wouldn't bore you much with it in terms of going through, but in terms of getting the intensity, we just subtract the rural area temperature from the urban temperature, and that difference will give you the intensity. Now, when it comes to the urbanization effect, this is for us to see the contribution of UHI, the contribution of the urbanization on the UHI. And out of this, it's just a difference between the urban area minus the rural area. Now, we chose Tema to be the urban area because when we looked at the classification that we were doing, we realized that over Tema, where the site is, that's for the GMET data, the surrounding area was much more urbanized or built up than the one that is in Accra, that's around the airport. So based on their land cover classification within that area, we decided to use Tema, or Tema was classified as an urban, while Accra was classified as a peri-urban or assumed to be a rural area. And out of this, the values that we get, so when you have a value of UE, which is bigger than 0, then this implies an enhanced UHI effect due to urbanization. That means urbanization caused the UHI to be enhanced. If you have it less, then it means that urbanization, the other factors contributed to the enhancement of the UHI rather than urbanization. And when it is 0, it implies that it had no influence on the temperature trends. That's urbanization does not have any influence on the temperature trends. Now, there's a level of contribution as to how the urban area contributed into the effect. And this is also done using this equation. So it was a percentile, a relative form. So 0 to 100 indicates no contribution to a high contribution. But there are instances where you would have level of contribution which is greater than 100%. And this indicates either an influence of unknown local factors or an error in the data. So sometimes if the data itself has a lot of errors in them or is not consistent, then it becomes very difficult getting this value. And therefore, you may run getting higher values than the 100%. However, there are other ways where you have a very good data set, but you run and you have higher value. And this will indicate that there are influences which are unknown and there are local factors as well. So from all these things, we decided to run all these processes and then to get our results. Now, from this results, you could see this is a change in the land cover. That is a spatial distribution of urban growth in Accra. Now, the blue areas are the water bodies. The red is the urban area. The vegetation is the green. And then the yellow is for low vegetative area and sometimes bare soil. Now, if you look from the A, which is the 1991, the green part was covering most of the region than the red part. And as time goes on, when you look at the changes, you see how the red part, which is the built up, is eating up towards the north of the region. And this shows an increase in the urban area, or there's an expansion in the urban area. And this area is the data sets for airports and then the Tema, which is around the harbor. Now, when you look at the statistics for the period, you'd see that for the statistics, you see that in 1991, water covered about 20% of the land, and then built up was about 13% thereabout. And then vegetation covered the most. And then the least was the low vegetative areas. In 2000, you could see that the water did not really change much, but there was an increase in the urban area. And then there was a reduction in the vegetative cover. And there was also a change in the bare lands or the low vegetative areas. And when you come to 2017, to see not much of a change in terms of water, but in terms of urban area coverage, it had increased past 30%. And there was a tremendous reduction in the vegetation cover when you look at what we see in 2017. And then there was an increase in low vegetation as well. Now, this is the change for the period. So 1991 to 2000, this is the change that we observed. And then 2002 to 2017, this is the change. So the large decrease in the vegetation cover is what we observe here. And then for the entire period, this is how it has changed. That's from 1991 to 2017. Now, when we look at what we have here, this is a spatial distribution of the land surface temperature and then the corresponding land cover. Now, you see that all these green areas that we have with time, as compared to the kind of temperature that we feel, you would see that the green areas were corresponding to low temperature, whilst the red areas were corresponding to warm temperatures with time. Yes. So when you see the change, so with the change that you observed, you see that there's these areas, which are the built-up areas, are covered in red, which means the temperatures are high within those areas. And these areas corresponded with the built-up area, while the blue area, which is relatively cold temperatures or less warm, corresponded to areas with high vegetation. And when you move to the 2002, similar thing could be observed in terms of the change. So you would see that the land cover area, which were built up areas in red, corresponded with the high temperatures, land surface temperatures, whilst the cold or relatively cool areas corresponded with vegetation cover as well. And this was also the same for the 2017. So you see that when there's an increase in urban area, the high temperatures also increase in terms of extension. And this is as a result of the land cover type that we have. So this is also having warm or warmer land surface temperatures than the vegetative cover which we see. So out of this, when we make our plot like this, you see that for water surfaces, the temperatures were relatively low, while the built-up areas, temperatures were relatively high, and the vegetation cover temperatures were also low, and then high over bare soils as well. Now, with the field urban thermal field variance index, very high values of this indicates worst effect of UHI. So you see that the worst effect of UHI is being observed over the built-up areas, while low effect of UHI is being experienced over the vegetative cover. And this is similar to also the bare soil. Now, the bare soil is having high temperatures because, or the low vegetative areas are having high temperatures because most of these areas do have less water content, and also because of their land, because of the surface cover type, there is more of a sensible heat, which gives out high temperatures within those places. So that is one of the reasons why you would also have bare soils or low vegetative areas having high land surface temperatures. So when you look at the statistics, you see that from 1991 to 2017, you see that the mean temperature was increasing with time. And this is an indication that as the vegetation decreases or we change the land cover, the temperatures also change alongside with it. There's an increase in the land surface, the mean land surface temperatures. And when you look at the threshold that we calculated from the land surface temperatures that we had, you see that the threshold in 1991 was 27.70, and this increased with time as well. So because of the way it is calculated, it is relative to the temperature that is being felt within the area, and then it uses that one to calculate. Therefore, it can be compared with any other year in terms of the threshold. Now, if you look at the area coverage where this threshold was covering, in 1991, you could see that it was covering about 22% of the area. But in 2017, about 50% of the land or the steady area was being influenced by urban heat island. And the intensity also varied with years. Now, this intensity, especially in 2002, was as a result of a compactness in the area, especially around Tema. So that increased the intensity. But if you look at the threshold and then the area coverage, you will see that it had been increasing with time. And this was similar to the UTFVI that I was explaining. So UTFVI from 0 to about 0.005 is a weak effect. And then this, as it increases above 0.02, we have the strongest effect. And this correlates with, this is ecological evaluation index, which is an ecological stress as in urban temperatures and their effects on the ecology or the ecosystem. And this runs from excellent to worst. So when you are having the strongest effect of urban heat island, you are having the worst thermal comfort or the worst ecological stress. And this increased with time. If you look at from 1991, which was covering about 32% of the land, but by 2017, it was covering about 54.5% of the land. So this means that in terms of the worst effect of UHI, it is also spreading, then moving along with the changes in urban areas. Now, when you look at the trends that we calculated from the extreme events, we saw that when over Accra, we are having a positive increase in terms of the average maximum temperature. So the average maximum temperature was increasing at this rate, that's per decade in Accra. And then over Tema, this is the rate at which it is increasing. But Tema, the rate at which it is increasing in Tema here was a bit faster than what we observed in Accra. But out of this, when you look at the ones that are related to the minimum temperatures, you see that the fastest increase are always, especially in minimum temperatures, are always over. And this I would also explain when I get to the discussion aspect. Now, when you look at the coldest day and then the coldest night, we could see that the coldest day, the temperature for the coldest day has increased over time. So assuming the coldest day was, let's say, 30 degrees Celsius, this may have increased to about 30.1 degrees. And then similar thing was also observed in Tema as well. And when you look at the reduction, those ones that the trends are reducing, you could see that the diurnal temperature range, there's a reduction in that. I'll also explain that aspect of it. And then the amount of cold days. So the number of days that we consider to be cold are also decreasing. And then the number of days the number of nights that we consider also to be cold during the night are also decreasing. So there's a decrease in the cold extremes, whilst there's an increase in the warm extremes. And this affects, as I explained with the UE, those that are greater than, and then those that are less than 0. These are also the trends that we see as well. So out of this, when we look at the changes that we observed in terms of the land cover area, the changes, there was an increase in the urban area, which is from 13.6% to about 31.6% by 2017. And this is this tells us that there's an expansion in terms of the urban area. The tremendous reduction in the vegetation cover, which we observed from 59% to about 24.2% coverage by 2017. And this shows that it is making way for the vegetation, making way for built-up areas. So you're cutting down a lot of trees, trying to build, trying to construct roads and many other things, and at the expense of the vegetation cover that we are seeing. And the kind of expansion that was observed in 2002, which led to the high UHI intensity, we call it the urban conurbation. Now, the urban conurbation is where you have an urban area where there is a growth within the urban area itself. So there's much more compact within the area, which is normally we termed it as polycentric. And then the one that was observed in 2017, we call it urban agglomeration. So that's when you have nearby villages and other cities. At the end of the day, you see that they are all coming together or joining and then forming one big area. And that is what we observed from the land cover change that we had. From the urban heat island and the thermal comfort, we realized that urban heat island actually exists in Accra, and it has varying intensities. And then the spatial extent was also increasing with time. And this is as a result of the rapid urbanization that we are observing. So an increase in the urban area was contributing to the increase in the UHI effect and the spatial extent. And then the strongest effect of the UHI that we observed suggested that there was a worse thermal conditions and ecological stress that we experience. And this is also increasing in terms of spatial extent. So what this is telling us is that as the urban areas are increasing and then we are having much more of an activity, the effect that we are feeling from the UHI is becoming stronger and stronger. And the thermal stress that we are going through is becoming worse. And even though it used to exist over some small areas, this is increasing to cover other areas where urbanization is also reaching them. So when you look at the trends in the extreme temperatures that we also checked, you'll see that there was an increase in the frequency. So the rate at which we are having warm nights and then cold nights, this was increasing very fast. And then the intensity in terms of the warmest day and then the warmest nights are also increasing. Now, the decrease in the diurnal temperature indicates that there's a release of anthropogenic heat. Now, this is because we are finding the difference between the minimum temperature and the maximum temperature. Like I said earlier, the maximum temperature are noted to be the daytime temperatures, and then the minimum temperature is nighttime temperatures. Now, when you have urban heat island sitting over an area, I said earlier that it is much more pronounced at night, which means during the night time, that is when all the asphalt and then the concrete are releasing most of the heat into the system. And therefore, this adds up to the temperature that you record at night. So the temperatures at night would be increasing at a faster rate. And once they are increasing at a faster rate, when you check the difference between the warm and then that's the maximum and then the minimum, there will be a decreasing trend. So that is what is causing the decrease in the diurnal temperature range, and we are attributing it to the anthropogenic heat. Then there's a relative higher temperature in Tema, and then the warming is slow as compared to Accra. Now, when we check the data, we realize that over Tema, the temperatures were already high. And this could be attributed to the fact that Tema started with this being an industrial area and people moving there early, and then the Tema Harbor as well. So there were a lot of activities which were already contributing to the temperatures over Tema. However, this was not the same as it was in Accra. But with time, Accra is growing at a much faster rate than what is observed at Tema. And therefore, there is an increase in the nighttime temperatures much more faster over Accra than Tema. So that is what was observed. And then this is similar to, so the faster nighttime warming in Accra is a clear evidence of the contribution of urbanization on the extreme temperature trends that we are observing. With the urbanization effects analysis, so the lesser warming that was observed over Tema as compared to Accra due to influence from the local anthropogenic factors other than UHI. So I said that when we have UE, which is greater than the Z urbanization, but if it is less, then it means there are other contributing factors to the UHI rather than urbanization. And that is what was also observed, especially when you compare Tema and Accra. And then urbanization, as well as other known local factors, influence the nighttime warming that we experience. So it is not only urbanization that is influencing the nighttime temperatures. So there could be other factors which may be attributed to either global warming and other activities that exist within the area. So in conclusion, what we got from our analysis was that there was a rapid urban expansion and there is an existence of UHI within Accra, which is having a varying intensity. And also in terms of area coverage, it is increasing and expanding to cover more areas. And this has increased the warm temperature extremes that we experience in the region. So urbanization and UHI and other anthropogenic factors are contributing to the extreme temperature trends that we are observing in Accra or experiencing. And because of the fact that urban expansion is still ongoing, we are still emitting more, we are still cutting down trees, we expect that warming would continue with time and probably maybe worse. And then the effect of UHI may be much more worse than we may be experiencing today. However, there are some things that we could do to slow down some of these effects. And one of them is to enforce the land use legislation. So we should make sure that even if we are building, we make way for vegetation growth. We also make sure that we don't cut down trees that provide us with shade or cool the environment for us. And then there are some other policies that can be made to regulate this. We out of the findings to realize that the effect of UHI on human health were not assessed deeply. So there could be other investigation to check how human health is responding to this UHI that we have, and then how comfortable we are in terms of the heat stress that we are experiencing. And then we could also investigate the effect of UHI on, okay, so I repeated this. So what this point was supposed to be was the effect of UHI on pollution within the Accra city. So because it is having a warming effect, it could either increase or decrease the pollution that we have within some areas, and this can be assessed. There is already some study that is underway in terms of assessment of UHI and then the urban pollution as well. Strategies of mitigating UHI effect is also needed. So there are a lot of ways that we could take up to control urban heat island. But the most appropriate one, or the one that people talk about most, is the greening of urban areas. So once you provide a lot of greening, it helps in shading, it helps in cooling the environment, and this will prevent us from having much more effect from the UHI. So I would like to acknowledge the GMET for their data, and also the satellite Landsat, which was gotten from the US Geological Survey, and the tools that are used for this work as well. Thank you.
Thank you very much, Mr. Cosmos Senior Omega. It was actually an insightful presentation and also science inclined. Please, we'll give room for questions, but before that comes, I actually have some few questions to ask. My first question is with respect to the three images you showed, the ones with the inscription A to C. I'd wanted to know that, was there, let's say, a mean average, or let's say an average temperature calculated for each of the coastal areas with respect to the images you showed? And also, the presentation was much inclined to human health. I wanted to know that, is it also possible that it can have effects on our rainfall patterns, the temperature patterns, and also the pressure patterns. Hello, Mr. Cosmas.
Yes, hello, can you hear me?
Yes, please, I can hear you now.
Yes. So I was asking if this is the image that you were talking about. You were trying to ask the question.
Yes, please. This is the actual image I was talking about. So when you look at the image A, you realize the red areas are as not they are not as many as that of the image B. So I wanted to know that with respect to this, did we have, let's say, an average temperature calculated for each of the domains, and also if they could have an effect on our temperature pattern, the pressure pattern over the coastal areas, and also our rainfall patterns?
Okay. So yes, so I'll take you back to this calculation. So when we retrieve the land surface temperature, all temperatures that are greater than the mean of the temperature within the area plus 0.5 of the standard deviation. So this is what is going to give us an area that we can map out as the urban heat island area. I hope you get it. So any land surface temperature which is greater than this. So this is the mean of the land surface temperature for the area plus 0.5 of the standard deviation. Okay. Now, when you come here, you see that this is the mean temperature for the whole area. This is the mean temperature. That's the mean land surface temperature. So the equation is saying that the mean of this plus 0.5 times this, the standard deviation, that is going to give us a threshold of this. Yeah. So when you do this calculation, you're going to get the threshold of the 27.70. So any temperature that is greater than this temperature is actually an area where you classify as the urban heat island for that particular area. Yes. Okay. So once you do this, and this kind of calculation helps us to be able to compare for different years so that it will be much more relative to each other. That is why the threshold are even changing, and then we can actually be able to check for its spatial extent. And you were asking if with this, it is going to, is there any effect it's going to have on the pressure and rainfall trends that we have? Now, we know that with rainfall, if you want rainfall, there must be some convective activities, heat moving up into the atmosphere with moisture. You have condensation and then rain falls. So heat is also needed in terms of our rainfall. Heat is also needed in terms of the energy that it supplies to a certain system to sustain it. That is when you have a convective system or a thunderstorm, there must be some energy that is going to help sustain the system for you to have heavy rains and all. Now, when you have this heat island, one of the things that it can do is to support an incoming convective system where you would have much more rains or very heavy rains within the area. And it can also lead to you having a lot of thundery activities because you are having a lot of heat being released into the atmosphere. But it's having a two side of it. It can also help in bringing down or dissipate some of these, how do you call it, incoming storms. I think those who are much more inclined with the thermodynamics aspects will be able to explain it much further. But sometimes some of these things also prevent an incoming storm from actually affecting your area. So it has a two-way side to it. Both of them, whichever way, it is bad. Because if you're having very extreme rainfall or very heavy rainfalls with a lot of lightning and thunder, you know the effect that it comes with it in terms of the masses. And then when you are also not experiencing rainfall within your area, you know the kind of effect that it will have. So it is having both a positive and a negative effect on the rainfall. But you would have to assess within your area what the UHI within your area is causing. So this is also a further studies that people can also take up on. When it comes to the pressure, pressure and heat, we know how pressure and heat also relates. So this is also one aspect that it can also influence the pressure. Most of the time, we would think that once we have high heat, there may be a lot of convective activity. So uprising, low pressure systems, and then you'll be having rain falling and all. But also high pressure can also be associated with the heat that you also feel. So when you have high pressure systems also within the area, it also influences the UHI itself. So pressure system, high pressure, which you are having a stagnant air, which is not moving, and there is heating. Now you're already having UHI existing within the area. So it means the effect is going to be exacerbated. I don't know if you understand what I...
Yeah, I'm actually getting you. I'm getting you.
Yes. So that is, it's both of them, they are all in two-way affair. So you would have to analyze it to see the kind of effect it is giving you within your area. But much of it, again, you can look at it in terms of seasonality.
Oh, okay.
Yes.
All right. Thank you very much. Please, the floor is still open. So if anybody has a question, you can show by hand, and also you can type it in the chat comments so that we can read it to Mr. Cosmos for answering. Please, we are still waiting on questions. Okay, Mr. Cosmos, there's actually a question in the chat box. Let me. Okay, please, somebody is asking, how was the threshold temperature determined?
Okay, so the threshold temperature for which one? Yes, please, can you hear me?
Yeah.
Is it the threshold temperature?
Yeah, I can hear you now.
The threshold
person was
temperature,
asking
is it
how
for
it
land
was
surface
determined.
temperature or the extremes?
He wasn't specific.
Yes.
But I'm sure
But when it comes to the land surface temperature, I think I showed. So with this one, what we term as a threshold here, we use the mean value for the steady area. This is the mean temperature plus 0.5 times this, the standard deviation. So the threshold for getting a land surface, an urban heat island, is the mean temperature, which we observe for the steady area, plus 0.5 times the standard deviation. The same way if you want to check. So that's why the threshold varies with the year as you move along. I hope I have answered the person.
Oh, okay. Okay, we can actually take the next question from Mr. Antabimpong. So, please unmute yourself and.
Okay, thank you very much, Mr. Cosmos, for this nice presentation. If I can recall from your presentation, you mentioned that you use GMET dataset to get the stream temperature variables.
Yes.
My question is, I want to know the methodology or how you were able to get the various indices.
Okay, all right. So the the various indices, I got them from this table. So this is a standard one, which is by the ETCCSI group, when they got the extreme temperature indices to be used for extreme analysis. So extreme weather event and analysis. So here, if we want to, assuming we want to know, let's say for this one, so this is the coldest day. If you want to know the value for the coldest day or when the coldest day was, you have to get a maximum temperature, okay? Maximum temperature. Out of the maximum temperature, you look for the minimum. So if from 1980 to 2017, out of your data, you are having data ranging from, let's say 25 degrees to 35 degrees. Your minimum will be 25 degrees. That's for the maximum. And that will tell you that that particular day is the coldest day out of the period. So the reference period that we used in terms of estimating this value was the 1980 to 2010 reference period. That was as at the time we were doing this work. And the same way, if you want to look at for the warmest day, you look at the maximum temperature that exists within that period. So if, like I use the 25 to 35 degrees for the maximum within the period, then it means 35 degrees, which is the maximum value, will give you the warmest day. So the day on which this temperature was recorded is your warmest day. So that's how the analysis was done.
Thank you.
Please, we'll be taking our next question from Mr. Enoch Dixon. So you can unmute yourself whilst you ask the question.
Yeah, hello, good morning, Mr. Cosmos.
Yeah, good morning.
Yeah, nice presentation, by the way. Please, I would want to know that how does the urban heat island phenomenon impact the overall climate and conditions over the study area?
Okay, thank you very much, Enoch. So when you have an urban heat island sitting over your urban area, it has a lot of effect on the climate, in the sense that it is actually introducing much more heat within the area that, within the steady area. So in this sense, that's why we realize that the temperatures are increasing at a certain rate or faster rate. And when you compare, you see that nighttime temperatures are even increasing much more faster than the daytime temperatures. And this is because much more heat is retained in your system. So it is acting like a cap that is not allowing a lot of heat to escape your area. So once you have a high heat, all the effects that you could get from high heat, you are going to experience it. It is going to affect the microclimate within that area in terms of rainfall, like I explained earlier. It is also going to affect the temperature, and also issues, especially with pollution. It is also going to affect it, and it is also going to exacerbate issues of heat waves as well if you have them within the area. So it has a lot of effect on the climate. It has a lot of effect and introduce some anomalies into your data as well. So that is one of the reasons why GMET data, when they are picking it also, the area is set out to be away from a built-up area and all those things. They have some specification for the enclosure to make sure that some effects from those area, the surroundings are not affecting the temperature. But with time, once the temperatures are increasing as a result of the urban heat island, it's going to get itself introduced into the data sets, and you'll be able to see them from there.
Okay, thank you very much.
All right, thank you, Mr. Dixon. Please, there's also a question in the chat box from Ms. Priscilla. She wants to ask what would be a more practical approach in mitigating against UHI, given an instance in Accra or Tema?
So a much more practical. Well, when you see from the analysis that we did, you realize that vegetation have the least temperature relatively. Vegetation and then water surfaces, and then built up areas do have the highest temperature. So one of the ways that you can actually go by is the greening. So within the urban areas, we must set up more parks where people can sit and enjoy themselves and all that. But in a way, it is also sinking some of the heat that we also have within the area. Building a lot of parks, I think, is much more practicable than we resorting to the use of air conditioning. So because of this heat as well, a lot of people end up using air conditioning, and then the air conditioning will also bring out heat back into the environment. So you are introducing more heat into the environment, which is contributing to the effect again. So it will become a vicious cycle where it will continue and there will be no other solution. But an ecosystem-based solution is for you to have the green areas. I hope I have answered.
Oh, okay, thank you very much. Please do, or does anybody have another question to ask before we bring the meeting to a close? Okay, please, she says it is answered. Thank you. So please, I actually have an extra question. So with regard to the health aspects, I felt maybe it would have been more better if we could actually list some of the health effects or maybe the sickness that comes with the urban island heating. Hello.
Sorry, I'm not muted. Yes. We have, so one of the heat, the health aspect of it is we have heat exhaustion, right? We have heat stroke. We have other respiratory problems. So most of the time, like especially in Ghana, some people get stroke, or maybe all of a sudden the person gets stroke. We go to the hospital and sometimes it's been attributed to food you eat or you not exercising or something like that. But within the periods, you can also check to see what was the temperature, how was it, and could this have contributed to the person getting that kind of stroke? And here we don't really do that. So one of the things that we can look at is in terms of that. It also affects our way of it also affects our concentration levels. It's just similar to you sitting in a room where the room is very warm and you are feeling uncomfortable. You will not be able to concentrate. You will not be able to do things rightly. So it has effect on that as well. The gastrointestinal intestinal hemorrhage, which is the bleeding within your intestine, which some of the time is the major cause of the peptic ulcer that we see. So it could also be that the peptic ulcer patients that we have may have either gotten theirs from the effect of UHI, or sometimes the attacks are coming as a result of UHI. But most of the time we ignore these diagnoses. So these are some of the few health effects that we can have.
All right, thank you very much. Please, there's a hand raised by Mr. Goku, so please, if you could unmute yourself and actually ask your questions.
Okay. So,
Yes,
can you hear me?
Yes, please.
Okay. Good morning to everyone. I may have joined a bit late. I'm enjoying the whole conversation. And Mr. Omega, I saw a post on Twitter and I was really happy about the whole thing because I'm really, really interested in the sustainability of our urban spaces that we have, especially in our cities. Developed, so-called developed cities, not the developing ones. The developing ones are now coming, which means we have so much to do in terms of correcting some of the mistakes that has already been done in the developed ones. Okay, but my challenge is that bottom line, we are all just talking about the same thing. How we have destroyed the environment in terms of encouraging so much heat in our urban. We haven't been able to create the green environment that we need, because if you travel through Accra, for instance, you can see a lot of spaces that are unutilized, especially open spaces that are unutilized, which is also giving so much heat into the system. Okay. My question is that how are our institutions? You have done a fantastic research on this with the Metro agency, but the question is, how are these institutions avoiding working in silos to come together as maybe in any way at all they can to discuss some of these things and also generate policies, not necessarily government being on top of the game, but at least some of these institutions, passionate people who are within the institution that can help come together, create some policies that will mitigate some of the challenges we are facing in our spaces, as you rightfully said. And then secondly, also, I wanted to know how maybe I'm the first person to start that, but I'm asking if you have the resources to do that. I think it would be a very nice opportunity for us to keep discussing this on our spaces. We have Twitter space, which is now available to us. We have Zoom, we have all these things that are available to us. This shouldn't just be the first and then the last discussion that we are going to have on this. Okay. Sustainability is everything, especially Africa. We have the opportunity to do a lot in terms of not destroying so much that we have our predecessors have already done. We have the opportunity, we have learned a lot, we have gone to so many lengths. If we can come together, passionate ones amongst us, come together, discuss it freely, open-mindedly. It doesn't matter how much knowledge we have on this, but at least two heads are better than one. So my question is that, are you ready or thinking about it to open some platforms online or any way so these things can be discussed and see how best we can mitigate this?
Okay, so I'll take up from the first question. That is, in terms of the institutions working together. Now, one of the things that I always say is the fact that sometimes our institutions are not able to work together because of the lack of awareness. Now, there's much little awareness, especially when it comes to urban heat island. And because the awareness is not there, sometimes it becomes difficult discussing especially ecosystem-based solutions to some of these effects. So once they have no idea about some phenomena which can have an effect on them, and it is within their agency or institutions to take up those things, they normally don't discuss it. So that is one of the things, that's lack of awareness. That's why institutions sometimes don't work together. And then, so this leads to the knowledge gap. So there's a big gap in terms of the knowledge, especially when you want to do research on some of these things. because there is no awareness on this, hardly will you have researchers also focusing their attention on some of these things and then going into it to look at what is happening on the ground. So because there's less research, there's not much of information on it, there's that gap. Again, the data that we use, even when you're assessing this, sometimes you need satellite data, and the kind of satellite data that sometimes you get, the resolution sometimes to have their own problems and all. The techniques in processing those kind of data sets and the tools we may not have. So it becomes difficult when institutions would want to work together to understand some of these phenomena and then find solutions to it. So there are a lot of things that is hindering the institutions from working together. But the last one that I'll put across is the official recognition of risk. Maybe I will just chip in this thing. Not until recently when we realized that a lot of people are using glue to hide themselves and all that, right? So the sales of glue was just the way it is. Anyone can buy glue anywhere and they use it for whatever they are going to use it for. But because now we are seeing the kind of effect that, or some of the bad things people are using it for, I'm very sure that going forward, the government or some health aspect may recognize it as an official hazard to us, and then we'll start restricting how we even, or regulate how we even use glue. So what I'm trying to say is that there's no official recognition of UHI as a threat, especially in our country. So because this official recognition is not there, it becomes very difficult for agencies to come up with policies to work against it. Because even sometimes when you fight through with the policy, it becomes difficult getting it done once it gets to the top. So that is what I would say about the institutions not working together, or what is preventing them from not working together. But there are a lot that are there as well. So of which I think you and I know very well. Then if your second question was if I am thinking of any platform to discuss some of these things and all. And once I get the platform anywhere in terms of conferences and all, that is when most of the time I discuss some of these things. We are looking into policy briefing to see how best we can write policy briefs, especially from our articles. Most of the time they sit online, and the people who are supposed to use it will not even care about it. But sometimes if you put them into policy briefs, they're able to get them and then work around it with it. So so that's how sometimes it happens. But for me, setting up probably social media and all those things, maybe it will be with time to discuss with other people. But right now, that has not really been the focus for now. If I may have answered your question.
Yes, please. You have. Thank you so much for.
You are welcome, sir.
All right, thank you very much, Mr. Goku. Please, do we have any extra questions? Please, if you don't have any other question, we could actually turn on our camera so we can take snapshots of everybody that has attended the meeting. All right, so please, can we turn on our cameras? All right, please, you are taking the shot, so if your camera is not on, you could kindly turn it on.
Say cheese.
All right, say cheese.